Hi, welcome to section 6.1, the Pythagorean theorem. We have two objectives. We're going to prove the Pythagorean theorem two ways, and then we're going to use the Pythagorean theorem. So first of all, I want to show you a great website that you can use for any topic. It's braincamp.com, so we're going to jump to it. And here's braincamp.com, and I'm going to go to topics. And you have all kinds of topics that you could talk about with your students, adding, subtracting fractions, areas of circles, and just tons of manipulatives for you to use. What I'm going to do is I'm going to scroll down to the Pythagorean theorem because that's the one we're going to use today. Alright, we're going to actually walk through part of the lesson because it's going to show us what we need to know. So here's our lesson.
A right triangle is a triangle with a 90-degree angle. The side opposite the right angle is called the hypotenuse, and the other sides are called the legs. The theorem states that if a right triangle has legs of lengths A and B and hypotenuse of length C, then A squared plus B squared equals C squared. Here is an algebraic proof of the Pythagorean theorem.
Okay.
Start by making 4 copies of a right triangle.
So first of all, we've got a right triangle, and the legs are A, B. Remember, the legs make the right angle. And then we've got the hypotenuse C. We were told that the Pythagorean theorem was equal to A squared plus B squared equals C squared. Alright, so what we're going to do is we're going to prove, hey, why is that true? And remember, the C is always going to be the hypotenuse, which is opposite the right angle. So we're going to first take the rectangles, or the triangles, and we are going to rearrange them so that we form a giant square, which is right here. Here's my giant square. Alright, I want to label my pieces. I said that A is going to be my smaller leg, so I'm going to label this A, and I'm going to label this A, and this A. So I just labeled all 4 triangles. I'm going to label B, which is my longer leg. And I'm going to label my hypotenuse, which is C, for each individual triangle. And remember, here's our right angles right there. There we go. Now, what we want to do is we want to prove areas. Okay, what we want to do here is we want to find the area of the shaded. Easy enough? Okay, we could do it 2 different ways. We could take the area of the big square and minus the area of the little square. Or we could find the area of each individual triangle and take it times 4 since there's 4 of them. So we're going to do both ways. We're going to first find the area of the big square. So the area of the big. And we're going to subtract the area of the small. And we're saying, well, you know, that was one way of doing it. The other way we're going to do it is we're going to take 4 times the area of the triangles. Okay, because there's 4 triangles. We're going to see if that's indeed equal to each other. So my area of my big square is base times height, which if you look, the base of the square is A plus B. The height of the square is the same. It's A plus B. We're going to subtract the area of the little, which is base times height, which is C times C, which is C squared. Okay, now the area of my 4 triangles, so the area of my triangle, so if I look at this triangle, it's 1/2 base times height, which is B times A. And since we have 4 of them, we're going to take it times 4. So I'm going to write in 4 times 1/2 a times b. We're going to see what happens when we solve all of that. So we're just going to do algebra now. Okay? So this is FOIL or distribute, however you want to do it. A times A is A squared. A times B is AB. Okay, B times A, which I'm going to write as AB, and then we have B squared minus C squared. Half of 4 is 2AB, because I distributed that through. Alright, AB plus AB is 2AB, so we got A squared plus 2AB plus B squared minus C squared equals 2AB. Hey, I can subtract the 2AB from here. Oh, those are gone as well. So that on this side we have equals 0. So we have A squared plus B squared minus C squared. But remember, we want A squared plus B squared equals C squared. So all we have to do is just move the C squared over. So now we have A squared plus B squared equals C squared. So that's how we prove algebraically the Pythagorean theorem. Okay, now what we're going to do is we're going to look at a different proof.
Now imagine forming squares at the sides of the triangles. The squares have areas A squared, B squared, and C squared. The Pythagorean theorem states that A squared plus B squared equals C squared. So the squares at the legs must be equal in area to the square at the hypotenuse.
Okay, so what she's saying is if we find the area of A and we find the area of B, it's going to equal the area of C.
Move the pieces from the squares with sides lengths A and B to the square with side length C.
Okay, so here's
and notice that A squared plus B squared equals C squared.
And here's the demonstration. So there's my A squared and there's my B squared. Indeed, it equals C squared.
Here is a different right triangle. Drag the pieces from the squares at legs A and B to the square at the hypotenuse to verify the theorem again.
Okay, so that's a nice little proof. Now here's another way of looking at it.
Here is another way to visualize the Pythagorean theorem. The squares formed at legs of length 3 and 4 will have areas of 9 and 16 unit squares. The square formed at the hypotenuse has 4 squared plus 3 squared, or 25 unit squares. The length of the hypotenuse is therefore the square root of 25, or 5.
Now let's do some examples. We're going to apply the Pythagorean theorem to find x, y, and z. Whenever you do the Pythagorean theorem, please write down a squared plus b squared equals c squared. Okay, here's my right angle. My a is going to be 3 squared. My b is going to be 4 squared. And we don't know c, so we're going to call that x and squared. Alright, this is 9 plus 16 equals x squared. 9 plus 16 is 25 equals x squared. And the last step to undo a square is to find the square root. So the square root of 25 is 5. Square root of x squared is x. So my answer is 5 meters. Alright, let's do the same over here. Don't forget to write down a squared plus b squared equals c squared. So I'm going to make that 6. B squared is my other leg, which is y. And I've got 10. Okay, don't ever forget the squares. So 6 squared is 36 plus y squared equals 100. Now let's subtract 36 from both sides. And we have y squared is equal to 64. The last step is to find the square root. So y is equal to 8. Alright, I have another example. Okay, once again, you write down a squared plus b squared equals c squared. A, in this case, would be 5 squared. B is 8. So you write 8 squared. C is z L squared. We have 25 plus 64 equals z squared. 25 plus 64 is going to be 89 is equal to z squared. Okay, find the square root. You can use a calculator, which I already have used it, and the square root of 89 is approximately equal to 9.4 is equal to z. Okay, here the example is we want to find the area of the box. Find area of the rectangle. Okay, so before we can find the area of a rectangle, hey, we need to find my base. So we have a right triangle. Our height is 7, so we got a squared plus b squared equals c squared. So this is 7, so we have 7 squared. We don't know our base, which is b squared. We know our hypotenuse is 12 squared. 7 squared is 49. 12 squared is 144. So we're going to subtract the 49. And we get b squared is equal to 95. Last step is to find the square root of both. So we have b is equal to the square root of 95, which is approximately equal to 9.7 meters. Okay, so we'll put 9.7. Now the last step is to find the area. Area equals base times height. So it's equal to 9.7 times 7. So that's going to be equal to 67.9 meters squared. And I believe I did that correctly in my head. Okay. Alright, we have one more example. What is the longest measure for a rod that can fit inside a semi-trailer with the dimensions of 28 feet by 9 feet by 8 feet? So here I have a semi-trailer, I drew it, and we're looking for the dimensions of this rod, which is right here. Okay, so if we have the dimensions of our trailer, this is going to be 28 feet. This is going to be 8 feet. And my height is going to be 9 feet. Alright, if we look, we have a right triangle that's formed with my rod, and we're outlining it in blue. There it is. The deal of it is, I don't know what this bottom leg is. So we have to find the bottom leg before we can find the rod. So then if you look on here, we have another right triangle that's formed. So we can find, and we'll call this x. We can find x. So let's do that. So a squared plus b squared equals c squared. My a is 28 squared. My b is 8 squared. And my c is my x. So I have x squared. Alright, so 28 squared is 784 plus 64. And we're going to leave that as x squared. We're going to add those two together, and I get 848 is equal to x squared. Last step, take the square root of them, and I have 29.12 is equal to x. So this is 29. We'll just round it to 29. Good enough. Okay, now what we're doing is we're looking for my question mark, which I am going to label it y, equal to 30